You guys are such troopers doing circles without me. I am trying to get back as soon as possible, but I'm going to keep you guys going on. Next thing we're going to talk about is tangent lines to circles. So before you even get started, I want you guys to notice this dotted line right here. Go ahead and cut a slit right there on that dotted line, and then fold each flap down over this black line right there, okay? So that way you have little flappies for your notes later. And then you guys will be ready for your notes. First thing about tangent lines I want you guys to know about is on the left. Zoom in on that. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn at the point of tangency. So this means in this case, in this picture we see right here, the cursive line L is tangent to circle S if and only if line L is perpendicular to line ST, the radius. Okay? And if they're perpendicular, that means at that intersection we would get a 90-degree angle. And we would consider this point of tangency the point of tangent to be T, because that's where the radius and the tangent line are meeting and they're making a 90-degree angle. The other situation with tangent lines are when you have two of them, like this. And in this case, it says that if QP, this guy right here, and RP, this guy over here, are tangent to circle C, then they're congruent. That means QP is congruent to RP. Okay. So let's try a few questions. For example, in number 1, find the measure of angle BCM. B to C to M. Well, I want you guys to notice one thing here. BC, right, that I'm kind of doing in blue, is a special part of a circle, and you should be identifying that as the radius. And then CM is part of a line that's outside the circle, barely touching the radius. So this is something from the first set of notes, kind of like this. If we have a radius and then a line outside. So when that happens, what kind of angle do we have? No math necessary. We would have a 90-degree angle. Okay. Let's go on to number 2. Find the length of CM if CM is 5x minus 9 and MZ is x plus 7. This one is just like the second thing we talked about at the top. So they're both those outside ones, which means if they are tangent, they are equal to each other. So 5x minus 9 is equal to x plus 7. Subtract x from both sides, you get 4x minus 9 equals 7. Add 9 to both sides, 4x equals 16, which means x equals 4. But they want us to find CM. So 5 times 4 minus 9, which is 20 minus 9, which means CM is equal to 11. Okay. Okay. Number 3, I'm going to warn you, is a bit of a tricky one because it does have factoring from Algebra 1. We haven't done a lot of factoring this year. Excuse me. Find the length of EM right here if we know CM and BC. So they pretty much want us to focus on this triangle, but they just don't care about that BE part. I know that the 90-degree angle for this triangle is right here. So I'm going to redraw this triangle just so I'm focusing on the triangle itself and not the rest of the stuff. I know the 90 is at letter C. BC is the radius and M's over by itself. I know CM is 12, and I know BC is 5. And the side BM has an E in between it, so I'm going to put that E in there. Because we're going to do a few things, and it'll come back to play in a second. First of all, we have what kind of triangle? And I hope you just said to yourself, a right triangle. So first of all, let's just start with solving BM. I know they didn't ask for it, but it'll make our life a little bit easier. So remember, when we are dealing with right triangles, missing sides, we're dealing with the Pythagorean theorem. So in this case, it's 5 squared plus 12 squared equals don't know squared. Please ignore my dog there. He's seeing something out the window. 5 squared is 25, 12 squared is 144. X squared stays x squared. So add the two together. We get 169 is equal to x squared. Then we take the square root of 169 and we should get 13. So I know the entirety of BM is 13. So I'm going to highlight BM. So the whole blue part is 13. But they don't care about the blue part. They care about the EM. So right here, they said BC was 5, which means we know the length of BE as well. It should also be 5. So I'm going to put a 5 in there. Now they just care about this missing part. Well, if I know the whole thing is 13, part of it is 5, I can subtract the 2. I can get 8, and 8 is my missing side for EM. Number 4 has us pull away from notes we had. Gosh, was it last unit? I think. I'm going to copy the same triangle I used for number 3 because it is going to be the same spot. I hate it when it does that. So we have BCM. We know the C is at the 90. CBM they're saying is a 60. So this is a special triangle. Snoopy. Okay, CM is equal to 13 root 3. And they want us to find BC. Well, if you go back to your 30, 60, 90 notes, this gives a lot away. And honestly, all I have to know is the front number is the length for the short side. So in this case, BC is equal to 13. And again, if you can't remember that, you need to go back to those 30, 60, 90 notes that we had a special note taker for. In number 5, again, we are dealing with that same triangle of BCM. So in this case, BC is 12. BM is 20. They just want you to find CM. So I just put an X. And this is just your Pythagorean theorem. You've done this so many times. I know you don't need my help for this one. Just make sure 20 squared, since that would be our hypotenuse, it's across the 90. It goes by itself. So 144 plus x squared equals 400. X squared equals 256. And remember, you have to do your square root. Actually equals 16. Okay, and in number 6, again, it looks like it's going to be Pythagorean theorem, but it's dealing with the other triangle, the BZM triangle. And we treat it just like we did the other side because of the tangencies. I have to make sure the 90 is the Z because that's the point of tangency where it touches the edge of the circle and it meets with the radius, and that's what's important. I know Z is the radius, it's the short side, and M is that long side. And then we fill in the picture. BM is 25, ZM is 20, BZ is X. So I'm actually going to leave number 6 for you guys to do on your own. I drew the picture for you. You are just plugging into your Pythagorean theorem, and you're solving for XE, okay? So I want you to pay attention. You are solving for BZ right now, which is a radius. But they want you to solve for XE, which is a diameter. So that's my hint to you that after you finish the Pythagorean theorem, you might not be done yet. Hint, hint, wink, wink. Give this a try. Hopefully I'm back either Monday or Tuesday and we can go over this.